Hello friends, let's learn comparison of electric field on axial line and on equatorial line. For this, we need a minus q charge and plus q charge. This is the center of charge. From this center, we are producing a distance at this point C. Electric field at point C is said to be E axial. Let the distance from O to C is R. In the same way, you take the bisector or line from the midpoint, then at a distance r, here the distance r, it is C dash point, here it is E equatorial. So E axial is along the direction of dipole moment and E equatorial is along opposite direction of dipole moment. This is point C dash, so this is E equatorial and here P is the dipole moment. From our previous topics, you know that E axial is equals to 2kp upon r cube, and you also know that E equatorial is equals to minus kp upon r cube. These are the two equations which we obtained from our previous derivations. Let us divide these two equations. So therefore, E axial upon E equatorial, this is equals to 2kp upon r cube divided by minus kp upon r cube. So you get minus 2 here. Let's multiply E equatorial to RHS side. So you have the formula E axial is equals to minus 2 E equatorial. Thus you learn that E axial is twice of E equatorial and E axial is opposite to the direction of E equatorial, which can be visualized from the figure also. Here E equatorial is along negative x-axis direction and E axial is along positive x-axis direction. So these two are anti-parallel, because of which there is a minus sign. Minus sign indicates that E axial and E equatorial have opposite direction. If you write in the term of magnitude, taking magnitude, then you have the formula E axial is equals to twice E equatorial. Now let's understand numerical based on this formula. A question for you is, we have a dipole moment. Let dipole moment, we have the charge. The charge is here minus 10 microcoulomb. Let this be plus 10 microcoulomb. Distance of two charges is 5 millimeter and R is equals to 10 centimeter. Here also R is equals to 10 centimeter. Then in this type of question you have to find E equatorial and E axial magnitude. So what you have to find? You have to find number A, E axial magnitude, and number B, E equatorial magnitude. So this can be done as E axial is equals to 2kp upon r cube. This is E axial. Here P is dipole moment. So you know that P is equals to Q into 2A. What is Q here? Q is 10 microcoulomb. So 10 into 10 to the power minus 6 is 10 microcoulomb. 2A is distance between these two charges, which is 5 mm. 5 into 10 to the power minus 3 in meter. So you have 50 into 10 to the power minus 9. Unit of dipole moment is coulomb meter. So write here coulomb meter. So here you get what is the value of P, which we are going to use at this place. So therefore E axial is equals to 2kp upon r cube. So here 2k is 9 into 10 to the power 9 and p is 50 into 10 to the power minus 9. What is r here? R is 10 centimeter. So this is 10 into 10 to the power minus 2 in meter whole cube. 10 to the power 9 and 10 to the power minus 9 will cancel because both are, it is plus and this is minus. Here you have 50 into 2 is 100 and 100 into 9 is 900. This is 900. And denominator side, this is 10 to the power 1, 10 to the power minus 2. So you have 10 to the power minus 1 into 3, that is 10 to the power minus 3. So you have 900 into 10 to the power 3, which you can write 9 into 10 to the power 5. This is E axial. Electric field unit is Newton per Coulomb. So you have Newton per Coulomb. Thus you find what is the value of E axial. What value you find for E axial? You find that E axial is equals to 9 into 10 to the power 5 Newton per Coulomb. This is, you have find this value. Now since number 1 you have determined, you have to find number B. So number B, you have to find E equatorial. This is equals to what? So you know the formula. E axial is equals to twice of E equatorial. You have the value of E equatorial. What is the value? This is 9 into 10 to the power 5. So you have 2 into E equatorial. Divide it, you have 4.5. So E equatorial equals to 4.5, 10 to the power 5 Newton per Coulomb. Thus you learned how to compare electric field on the axial line and on the equatorial line of an electric dipole and how to solve numerical based on them. Do like, share and subscribe my channel. Thank you.